Here's lesson 6-1, day 4, law of sines, where we're continuing with application problems using the law of sines. So here's an example that I took from the problem set just to continue with more practice. So the question says, a pier forms an 85-degree angle with a straight line of the shore. So here's our 85 degrees. This is our shoreline. At a distance of 100 feet from the pier. So here's your 100 feet. The line of sight to the tip forms a 37-degree angle. So here's your 37 degrees. Find the length of the pier to the nearest tenth of a foot. So we're looking for this distance right here, A. And we're going to use the law of sines. So let me just go ahead and delete that out. And I'm going to start by finding this angle in the triangle. Well, these two angles right here add to 180 degrees. They're linear pairs. So step one is to find angle B. So how you find angle B is you take 180 degrees and you subtract out that 85. So when we simplify it, we get 95 degrees. So this angle right here is 95 degrees. Now we have two angles in the triangle. So step two, use your triangle sum theorem. Find angle C. Use your triangle sum theorem. So angle C is 180 degrees, and you subtract out angle A and angle B. So angle A was 37 degrees. Angle B we just found to be 95 degrees. And when we subtract those, we get 48 degrees. So angle C is 48 degrees. All right. So right now we have 95 degrees sitting at angle B. We have 48 degrees up here. We're now able to use the law of sines because we have an angle and the side opposite. You have to have a pair, big C and little c, which we do have. And now we're going to work with big A and little a and solve this by the law of sines. So number 3, find A using law of sines. So we set up our equation with our proportions. The sine of A over A equals the sine of C over C. Now we substitute in our values. Angle A is 37 degrees. Side A is what we want to find. Angle C is 48 degrees. Side C is 100. Now we're going to cross multiply and undo, which we've been doing already these last few days. So A equals 100 sine of 37 degrees over the sine of 48 degrees. We would type that into our calculator and make sure that you are in degree mode. And A is about 81 feet. So that distance right here, from the length of the pier down, is 81 feet.